Hello, everyone! Let's continue our golden phoenixes. A tutorial on the sky. In the last class, we've talked about the basic settings of the sky, global illumination, weather and night sky. In this lesson, we will talk about the cloud effect. First, it is one of the most powerful. One of the most powerful plusions. Which is our cloud layer. Our cloud layer has basically been, which is fully built in. Perfect volumetric cloud effect, which gives a lot of settings. Today, let's take a look at what are the settings of this cloud layer. Firstly, the first part is the quality settings of the cloud, which are low, medium, and high, which corresponds to low, medium, and high respectively. Render the entire cloud with a 1/16 of the screen. Media is a quarter of the screen. And high quality is 1:1. So let's take a simple look. For example, for a cloud like this, we can see that it is a bit blurry. If we change it to media, it will be clearer. If we change it to high, it will be very clear. But at the same time, let's look at the lower right corner, the FPS of the entire area. We can see that if I change it to, when I change it to high, it can guarantee 60 frames per second. When I changed it to media, it will drop a bit. When it's high, it will drop even more. Of course, because I only have one. You can see that it has dropped to more than 30 frames. High is relatively more stuck. Well, generally, we recommend low. At most media. So generally, we don't recommend high, because our clouds are in 1/16, 1/4, and 1:1. We use a lot of techniques to upscale it, which means we expand it from small to large. There won't be particularly obvious problems. Especially, we also use temporal accumulation. Techniques on a time series. To put the calculation result of the previous frame. So it can keep our D within an acceptable range. So I recommend that you use D normally. In a case where the cloud layer, we may need to use medium or high. When might we need to use media? When the clouds stand in the clouds. And look at the clouds diagonally from the middle. We can see here, there are obvious noises. Only in this case, we can turn it into media, or even high. Generally speaking, when we look at clouds on the ground, or we look down on the clouds from a high altitude, there is no need for this thing. Okay, this is the quality of rendering. And below will follow too. One is called the main step count, and the number of light source steps, because our entire volume cloud is achieved through a light stepping technology. How does the light step? First, from my perspective, a perspective to look at the cloud, step by step. And every time it sees a point, it will look at. And then look at the light source step by step. In this way, we can make the backlit part of the cloud is dark, and the bright lights and fluorescent areas are bright. We can adjust the entire the effect of the sun. You can see that when the sun is setting over there, the backlit area is brighter, and the fluorescent area is darker. It is such an effect. This effect has two steps. These two steps are respectively from my perspective, the clouds stepping and the clouds stepping towards the light source. The settings for these two steps are also here. The first step is defaulted to 48 times, and the second step is 8 by default. If we increase the first step to increase, then there will be fewer flashing points, and it will consume more performance. The light source step is the same. Generally speaking, I recommend the main step number. If you have high quality requirements, I recommend the maximum to 19.6, which is twice of 48. If it's higher, it will be very laggy. The light source step is generally okay. This is the rendering quality of the entire cloud. Is the default setting. This is the best option for most projects. And below is the cloud height. The cloud height. Cloud height and cloud thickness are actually an auxiliary effect. First, we need to ensure that the cloud height is above the sky. We can't set the cloud height to low. Meanwhile, the default cloud thickness is 8,000. It can be changed to a lower value, such as 6,000. The cloud height is from the ground's zero elevation to the lowest point of the cloud. Then the thickness of the cloud is the continuous space. Of course, let's take a look at the duration of the cloud. Here, the cloud thickness is set to 8,000. In fact, the cloud is obviously not 8,000. Why is that? It's because of the type of cloud we selected below. Only cumulus clouds can fill the entire cloud layer. We can see the effect of cumulus clouds. Cumulus clouds will fill the entire cloud space. Cumulus clouds are at the bottom layer. Middle level clouds is in the middle layer. Double layer clouds have both cumulus and middle clouds. And our high-level clouds are set on the cirrus side. So, generally speaking, if you only look at the ground, and only on the ground. I recommend you directly use cumulus or middle cloud. So the overall cloud quality is the best. If you want to add a little bit, the layering of the entire sky, you can use the double layer cloud. You can see that there will be 2 layers of clouds in the sky. And if you need to simulate a rainy time, you can use cumulonimbus clouds. Cumulonimbus clouds. It requires high quality because the thickness of the cloud layer here is set very thick. We can appropriately set the cloud thickness lower so that the cumulonimbus to be higher. You can see that after we set it to cumulonimbus, the noise is still very obvious. We can appropriately increase the number of steps. So for the base cloud, it has the meaning of adjusting the step path number, but it's meaningless for other clouds. Okay, let's go back. Generally, I recommend you to use base clouds. Middle cloud or double layer cloud is enough. You can see that the quality of the base cloud is very high. Okay, after talking about the entire cloud height, we have just briefly the cloud type. Let's take a general look at it first. Our cloud layer is divided into 2 layers. Let's take a look at it from the air. First is this layer, which is our cumulus cloud. Stratocumulus. This layer, its clouds are mainly consists of water vapor. As the altitude increases, we can see another layer of clouds in the sky. We call this layer cirrus. Cirrus is composed of ice crystals. Let's pull the cumulus cloud down to see. We can see very clear cirrus clouds. Sometimes there is no cumulus cloud at all. We can directly pull the cumulus cloud. The cumulus clouds very low, and then we can directly see the cirrus clouds. Sometimes there is no cirrus. Our cirrus can also be pulled to 0. That means there is no cirrus cloud in the sky, only cumulus clouds. The specific sky effect. The effect is up to you to set. And I've just introduced the entire cloud types. We currently have 4 types of clouds. And then there is a cloud control below. We default to a progress bar, which is the proportion of clouds. If you pull it down, the cloud will take up less space. Pulling more will make the clouds cover more. We feel it more obvious with double layer clouds. If we stand on the ground and look up, if you pull it up, it will cover the entire sky. If we pull it less, there will be. It will have a feeling of 1 by 1. Of course, we can also have an advanced setting, which is to set details for the entire shape. Click Advanced. We can see what settings we have. First, we can, just like the cloud coverage. We have a cloud covering here. We can increase it. Okay, the principle of this is the same as before. Meanwhile, we can control the density of the clouds. This so-called density is the cloud. the amount of water in this layer of cumulus clouds. The higher the water content, the higher the density. I set it to 0.35 by default. Let's zoom it out. You can feel it. Then it is like this, which is equivalent to having a lot of water inside. It can't penetrate the whole cloud. If we make it smaller, its light transmittance will increase. The whole cloud will look very light and airy. We can see this at dusk. It will be more obvious because at dusk, the sun passes through many clouds. If the clouds have high transmittance at this time, the whole sky will look brighter. Let's take a look. Okay, you can see that the cloud is very transparent. The cloud transmittance is slightly lower because the sun is here. It passes through the clouds. The clouds are thick, so it will be very dark. So this is very helpful for you to adjust. The basic effect of clouds is very helpful. Okay, let's switch to a normal daytime. The default setting is 0.35, which is a relatively middle number. It will be better. The texture will be the best. Below is the shape repetition and shape change speed. Let's first look at the shape repetition. There is such a large cloud in the sky. It is made with a random algorithm, and it's made by typing. The more the shape repetition, the smaller each cloud will be. But the stronger the sense of repetition. Let's change the repetition to 1. Let's take a look. Okay, the whole cloud is very large. And the degree of repetition. And the sense of repetition is not strong, but each cloud is very, very large. Let's take a look on the ground. Each cloud is very, very large. At this time, we are very suitable to build. I don't know if you've seen this kind of sky. In the sky, there are very, very many small particles. These clouds generally indicate that we can tell that it will rain tomorrow. We've been making clouds for a long time, so we know clouds very well. If there are such clouds in the sky, it means it's likely to rain tomorrow. So when you imitate this kind of cloud, you can use this shape with only 1 repetition. If we increase the repetition, you will see many small clouds. If we lower the cloud coverage slightly, it will be more obvious. Let's look at it from the sky. Okay, let's increase the cloud repetition. Okay, each small dot of this cloud is very small, but the repetition is very obvious. We can see that the distance is actually repeated. Let's look at it from the ground. It'll look like this. Of course, the specific effect depends on adjusted by yourself, since it's called advanced. If you know it well, you can adjust it. We recommend the default value. If you are not familiar with it, just use our default values. Okay, we can see that these default values are a relatively suitable state. The next one is the shape change speed, which is easy to understand. We can see that there is a lot of water vapor in the middle of the clouds. Under the sun's irradiation, it will have a rising effect, which will cause the entire cloud and disappear for a while, and then appeared. Such a sense of change will enhance the feeling of time passing. Our default change speed is 800, which is equivalent to an upward wind of 800 meters per second. We can make it faster. You can see the clouds changing very fast. Of course, we can exceed this. Let's take a look. If we make it feel like time-lapse photography, the change will be very fast. You can adjust it by yourself. We have given a relatively moderate speed. Reset to return. Reset it back. Okay. The cloud erosion degree. This is actually a detail of the cloud shape. That is to say, in our clouds, there is a large shape and a small shape. What is the small shape? We can see on the edge of the clouds. These one by one. We used to call them clouds, right? Because besides the whole big shape, there are many small shapes in the middle. These small shapes also have a degree of repetition. We defaulted to 70%. If we set the repetition rate very low, you can see that these small shapes will basically disappear. If we set the repetition rate very high, the small shapes will be very fragmented. This is still up to you to adjust. Let's reset it. Of course, the intensity of these small shapes can also be adjusted. We can also make it completely disappear. We can look at this kind of cloud in the real world. Basically, do not exist in the real world. But if you want to do some stylized things, you can also use this kind of cloud. Similarly, we can set it to 0.9 by default. Of course, it doesn't matter if it's 1. The speed of sleep and food changes. This is the same as the shape change speed. The shape change speed is a large shape, while the sleep heat change speed is a small shape. We can pull it up equally. You can see. If we pull it up a little more, you can see this feeling. There is a feeling that there is an upward wind, constantly making it change. Let's take a look down there. It feels like this. The whole of this area. Various parameters. We can adjust various cloud effects. Of course, if you still think it's not enough, and think we need a more complex effect of the cloud layer, we can use our cloud map. As the name suggests, which means we use a picture to represent clouds. I've already talked about this. I've already explained it to you. We can even put our logo in our cloud map. We can refer to the cloud map. The separate course of that chapter. I won't demonstrate it to you here. I'll just give you a brief explanation. First, after we open the cloud map, we need a black and white image, where white represents clouds and black represents no clouds. The intensity of white represents the density. That means we'd better. We should use white with a value of 0.4 to paint a piece. It will be the same as the current effect, but it will follow the shape we draw. This kind of cloud map is actually very suitable for us to do a storm in the sky, snowstorms, thunderstorms, and storm clouds, even typhoon clouds, so that we can see them in the sky. I won't demonstrate it to you here. Okay, let's finish talking about our low-altitude clouds, which are made of water vapor. Let's take a look at our high-altitude clouds. We just turned off the high-altitude clouds. Let's pull it apart and take a look. High-altitude clouds are made of ice crystals. It is a thin layer of clouds. We can often see this layer of clouds in the sky. This layer of clouds, our settings are relatively simple. First, there is the cloud proportion. The smaller we pull, the lighter it is. Secondly, it also has a density. The higher we pull it, the lighter and denser it is. The denser it is. Meanwhile, we give this cloud 3 different looks. Let's turn off the stratocumulus first. Okay, let's use simple. Okay, we can turn off the stratocumulus to this extent. There is no direct switch for stratocumulus for now. We can just turn it off to this extent. Then let's look at the different cirrus clouds. Let's pull it up more to make it more obvious. Look at cirrus. I usually recommend you to use a roaming camera. The roaming camera can look up. We can finally look up at the sky. Let's take a look at different cirrus clouds. We have stripes now. Actually, this is the most common cirrus. We can also change it to flocculent to achieve this effect. You can take a look. Cirrus clouds also moved. We'll talk about the independent wind field behind later. You can see that. In fact, the cirrus cloud is moving towards that side. Later, we may separate the wound fields of cirrus and the wind field of this stratiform cloud, because sometimes when we look at oblique photography or some time-lapse photography, we will find that the clouds at the highest altitude, the direction of movement of clouds are in the same direction because our Earth is very high in the atmosphere. May be different at different altitudes, but the wind direction may be different. Our current wind direction is the same. Okay, let's continue to look. We also have a point cloud. It's a dotted cloud effect like this. The effect of cirrus clouds. We can also increase the density a little bit. The density of the cloud may not be so high. We can lower the intensity of this. Lower the intensity a bit. It will also create a dotted cloud effect. This effect is actually something we often seen in our real sky. If we add a layer of stratus clouds, we can see the entire sky cloud layer. The texture of the whole sky. It's very, very layered. So this is also one of the most powerful functions. One of the most powerful functions, which is our sky cloud. Okay, after talking about our clouds, which is equivalent to the modeling process, let's talk about its movement and its color. First, the color of the entire cloud is actually the default, is the result of the interaction of our atmosphere, our sky, and the ground. We have adjusted the light for you. Let's take a look. Suppose we can even see the clouds of this kind of dusk. It gives us a feeling of burning clouds. If we make the cirrus clouds stronger, a little stronger, adjust the strip cloud and make it stronger. And then we can appropriately adjust the intensity of the sky. Let's see how much sky intensity is given now. We can increase the intensity of the sky. We can see a very classic state of dusk. We can see that the sky is very dark. Meanwhile, if we want the clouds on the ground to be a little more transparent, as mentioned before, we can lower the intensity of the stratocumulus. The intensity of the stratocumulus we can see like this. Then lower the intensity of the stratus. Okay, like this. We can make a very beautiful the effect of our dusk, and even see the starry sky. So the color of the entire cloud doesn't need to be set. But sometimes we may encounter a situation, such as at night. During the night, our clouds may be affected by and pollution, and some colors will be added. At this time, we can actually set the scattering colors of the clouds. Of course, in the future, we will directly add. The airglow and pollution will also be added. So we don't need to use scattering colors. Scattering colors. We understand that this is a artist's settings. That is to say, if you don't want it to be a physical composition, but you want to give it a very dramatic sky, then we use scattering colors. We also need to adjust the density back first, because it will look too white. Okay, we want to use scattering colors. Let's take a look. Suppose there is a red. And we don't know what particles. Okay, we can change it to a pinkish sky. We can even do this. We can do some stylish effects. But generally speaking, I strongly do not recommend you to change this, because changing it must be unreal. Of course, there is another scenario. There are a lot of lights on the ground. At this time, it can actually be reflected in the sky. For example, the neon lighting effect in the night scene. At this time, you can also change the scattering color. Okay, the remaining is the wind field. By default, clouds use an independent wind field. The so-called independence means that the overall weather's global wind speed, which is a separation. The global wind speed will not affect the wind speed of the clouds. The global wind direction will not. The wind direction of the cloud layer. However, we can also cancel this independent wind field. It will use the global wind speed. If we use the independent wind field, it will use the wind speed of the clouds. The cloud wind speed is also very simple. Let's take a look. Now the default is kilometers per hour, which is kilometers per hour. The reason why we use this unit is because this unit is relatively small. Otherwise, the meter per second is too large. The final number is too large. It's hard to control. Generally, our real wind speed is in meters per second. Everyone needs to convert it. Okay, let's go back and forth. Let's set the cloud layer first. This cloud layer seems a bit too bright. Because we have adjusted the color of the sky, so the clouds will be relatively brighter. Okay, let's take a look directly. We'll increase the clouds and wind speed. Okay, you can see such a very obvious time-lapse photography effect. The whole cloud will move in that direction. Of course, the wind direction is the same. Which direction do we want them to go? We can see. For example, we go this way, or the opposite direction, or over there, or to the left. This is up to you to adjust. This is also a very important thing, is to achieve the effect of time-lapse photography, such as the effect of day and night switching. If we add such a cloud animation, and then add the time-lapse of day and night in front of us, if we speed up the time to 1 minute, we can make it like this. We can achieve a similar effect to time-lapse photography. A minute might still be too short. We can make it the effect of time-lapse photography, which can be said to be very realistic. Let's speed it up a bit. The minimum is 0.5. If we add some, such as light flow animations and so on, the sense of time-lapse photography, the effect will be even better. Okay, this is the most basic one. Wind speed with the effect of time passing. Okay, let's go back to. Let's turn the wind speed back. Normally, the wind speed is definitely too fast. Let's reset it. Okay, after talking about the wind speed and direction, there is only one option left for clouds, which is the cloud shadow. I should have briefly talked about this before. We also have a separate course too, to talk about the effect of cloud shadow. Let me show you here. The cloud shadow, by default, will directly affect our GS, the GS image. And it doesn't need to set the entire shadow. A space range. When we talked about the scene earlier, we actually set the shadow of projection effect settings. For GS, it will directly have a shadow effect. The cloud shadow here is not clear because we move a little slowly. Let's increase the wind speed. Now you can see the very obvious cloud shadow. The cloud shadow not only follows the clouds in the sky and at the same time, but also change with the changes. So in the sacrificial scene, adjusting this cloud shadow is very beautiful. Of course, in ordinary scenes, because the general scene is relatively small, it is almost either covered by clouds or it will be exposed. It's hard to see the texture of the cloud shadow's edge. Meanwhile, in our ordinary scenes, in small scenes, we also need to set the sunlight and shadow of the sunlight in the sky. To adjust the cloud shadow, I should have explained this in the last class. I have already explained it briefly. We also explained it in the course of cloud shadows. I won't explain it here. Just open it directly in the notepad. The overall effect is already very good. Okay, our cloud is also the most important one in the one of the most powerful functions. Let's stop here. Let's set it back to the settings. After talking about yin, let's look at the fog. Actually, there are two below. One is called fog, and the other is called atmospheric scattering. They are actually both effects of fog. Let's not talk about the cloud and fog effects first. Let's talk about atmospheric scattering first. The blue light we see in the distance. This blue light is actually an effect of atmospheric scattering. In fact, atmospheric scattering is a kind of fog. We can see that. There are two of them turned on here. One is called Rayleigh scattering, and the other is Mie scattering. These two correspond to the air. Small molecules in the air and large molecules in the air. The so-called large molecules are longer than the light wavelength, which are larger than the wavelength of light. Small molecules are smaller than the wavelength of light. Generally speaking, Rayleigh scattering represents the scattering of such as air particles, such as air molecules, such as hydrogen atoms, helium atoms, and so on. Scattering of molecules. Mie scattering represents the scattering of such as PM2.5, PM10, and other pollutants. Scattering, which together constitute atmospheric scattering. If we turn off the atmospheric scattering, the effect will be very obvious. Our atmospheric scattering will automatically the entire scene and the sky and volume clouds in the sky will automatically merge. So under normal circumstances, the consumption of doesn't consume much performance. I recommend that you turn it on directly. At the same time, we also have an artistic adjustment. We can adjust the color of the ground. We can see here. The ground color adjustment is not obvious. The reason is that because for atmospheric scattering, we must see the ground. There is no need to adjust the ground color. Here, I'll use this. Let's find one that can see the ground. We can see it if we don't set a complete ground. We can see the ground and space. Let's take a look. Let's turn this off. This is my ground, which is completely black. Then I'll adjust the ground color. We can make the entire to lighten the color of the ground here. We can see that it will change the color of the entire ground. This ground color. This is purely an artistic adjustment. It will not affect the atmospheric scattering. The color of the sky. Of course, there is multiple scattering here. Multi-scattering means that normally, we have a single scattering effect. But in the entire scene, we are using a multi-scattering effect. I don't recommend anyone to adjust it. Just keep it at 1. Only in our air. That is, when light propagation is not convenient to propagate. It is necessary to lower the multi-scattering. Okay, after talking about atmospheric scattering, let's look at the height fog, which is our fog effect. You might think that our atmospheric scattering is already a kind of fog, and it is even a kind of high fog. Then why do we still need a height fog? This has many uses. For example, I want the distribution of our current atmospheric scattering is very uniform. Suppose I also want to make between mountains, there are some mountain fog. valley fog. This kind of fog is more in the mountains. The water vapor is not easy to disperse, which leads to fog. At this time, I can use our height fog. We can directly adjust the height fog. And evening. We can increase the height attenuation a little more. Set it to 15. You can see the fog effect in the mountains. Of course, this fog effect. We have it here. First, there is a height offset. We can make it not start from 0 elevation. We can let it start from the air. This is no problem. Meanwhile, our color. This color is an artistic color. After we adjusted it, it can create a polluted fog effect. Normally, we don't recommend adjusting it. The color is affected by the atmosphere, which is very important. If we turn off the color, it will only recognize this color. It will be completely black. Look, it will turn into a black color. Normally, we need to be affected by the atmospheric light, which is also affected by the sun. This is also very important. When we look at the sun, the light of the sun over there will illuminate. The fog at this angle will be illuminated. If we turn it off, the side facing the sun, the effect will change. Now the sun is directly overhead. Let's find the sun. Where is the sun? You can see that the hole. The fog effect will be slightly brighter. After we turned it off, the fog effect here. Now you can see that after turning it on. The fog effect on this side of the sun will be brighter. And then it will be darker when we turn it off. This is the default. Everyone turns it on. It doesn't consume much performance. I don't recommend you to touch it. Okay, the final maximum opacity. When we are on the ground, we look at this fog. The maximum opacity is. It means we can't see anything. It's what we call pitch black, right? Even if the fog is very thick. But we can make it not so bright or intense. It's up to 0.5. These are all artistic adjustments. Starting distance, disappearance distance. I don't want to see fog in front of me. For example, the fog starts from 100 meters away. The vanishing distance is where I go, where the fog will no longer be superimposed. The maximum side height, which is also very important. When we look at things from the air, sometimes we need to do that. Very large perspective. When looking at things in the air, we pull to the angle of the earth. There will be no height. If there are objects with height, you can't see them, but sometimes we need to adjust the height. That means when we make 3D maps, we need this when making 3D maps. Meanwhile, our height fog not only provides a set of height fog, but also two sets, which is our secondary fog. That is to say, sometimes for example, when I'm making the effect of mountain fog and add another fog, we can also use the secondary fog. Its settings are the same as the main. Are the same as the main fog? It's just an additional layer. Finally, let's take a look at the volume object. What does volume object mean? Let me open it. Wait a minute. Let me show you this. Let me show you. The fog effect is too strong now. Okay, let's go back to the volume object. Let's turn off the volume object again. You can see. Okay, the light of it. It will be more affected by the sun. That is to say, when our sun, there is already an effect of the sun in front of us. This is just a non-physical. Non-physical algorithm. If we want a truly physical algorithm, we need to turn on the volume object, but it is very performance-consuming. Here, I don't recommend you to turn it on. Okay, so this is our entire cloud and fog effect. Generally speaking, we only need atmospheric scattering. We don't need the fog effect, because the fog effect is actually a superposition of scattering effects. Of course, in some special scenes, you can use fog instead of atmospheric scattering, because the performance of fog effect better than atmospheric scattering. Meanwhile, if there are some requirements, visual hierarchy is required. You can also stack the two effects. This is up to you to decide. After watching the fog effect and atmospheric scattering, the remaining two are very simple. The first one is the bird flock. Birds are almost never used in such a large scene. After we turn it on, it will be concentrated in a very small area. We can't even see it now. For some small scenes, we can superimpose the bird flock. For example, in this scene. In this scene. At the same time, our flock has many implementation methods. Our bird's flock actually implements the aggregation algorithm of the bird flock, which can make birds form a formation while flying, and sometimes in a line, or in a V shape, right? They can form a formation. However, if you need one or two birds, you can directly in this. In our model library, find our human and animal models. Use this eagle. You can also use this eagle or a sparrow. You can configure it separately. Its path animation can also create the effect of flying in the sky. The path animation of this eagle, we have mentioned it in many tutorials. I won't talk about it in this tutorial. You can go through our other tutorials. Okay, let's try here. Let's try the birds in the sky. We click, and then the sky. You can see that the whole sky. Many birds appear. And as these birds fly, they will fly in groups and fly in groups. So this will greatly enhance the sense of reality of the whole picture. But the same, in such a large scene, we turn on, it's almost invisible. If you want to see them, we need to adjust a lot at this time. It may be very laggy. Look at this. We currently only default to 30. In such a large scene, it may need 3,000. You may only see this bird. The bottom of the bird group is an other. Allow selection. You may think it's inexplicable. Why is there an allowed selection? This is when we are doing the kind of. When we are making a 72-degree VR effect. That is, we are purely making a VR image, which is our panoramic image. We used a static sky for the panorama and set a panorama or an HDR cube map. At this time, I may need to directly click on the marker point in the panorama. But we can't click on the sky. Let's take a look now. When we are now in our sky, this marker point, I want to click on the sky. You can see that the mouse is it looks like a cross because we can't click on the sky because our sky is transparent. It is infinite. I click like this. I don't know where I'm clicking on the sky. But I can also allow the sky to be clicked. I turn on this allowed point, and then you tell me where it is clicked. You can see that I can click now. One click is equivalent to clicking on the sky 200 meters away from you. This is only useful when we make VR. When making VR panoramic images, it's not recommended to turn it on at ordinary times. Okay, today we'll talk about the second half of the entire sky, which is our cloud and fog effect, and also briefly talked about birds and others. Okay, that's all for today's class. Thank you all.